The essential question: what are some ways we describe waves? We talked in the last lecture about how there are two different types of waves, transverse and longitudinal. The parts of a transverse wave, this right here is the normal or resting line. That's just the center of the wave. If you think of this as water, and the water is nice and flat before you make a wave in it and cause a disturbance. The top of the wave is called the crest, and you can remember that like Sandia Crest is the top of the mountain. And the bottom of the wave here is the trough. On a longitudinal wave, which is one where the energy is moving in the same direction as the wave, like the slinky wave, this is called a compression, where the waves are close together. This is a rarefaction, where they're more spread out. So if you remember from the demonstration, we get these little clumps here of where the energy pulses are moving through. So those are compressions, and these right here are rarefactions. There are several ways we measure waves, and that's going to include wavelength, frequency, and amplitude. So we'll start with wavelength, which is symbolized by this little symbol right here. And one wavelength, okay, includes one wave. You can also measure from crest to crest or trough to trough, okay, but that is one wavelength. In a longitudinal wave or a compressional wave, you measure from the center of one of the compressions to the center of another compression. So the faster a wave is moving, okay, or the higher its frequency, we'll talk about that in a minute, okay, the lower its wavelength. So as these waves move faster, the wavelengths actually get shorter, and you get little smaller waves in here, more squished together. So faster equals lower wavelength. These are inverse. Next is frequency, and that's the number of waves per second, and it's measured in hertz, which is abbreviated Hz. So you can calculate wave speed, okay, by knowing the frequency and the wavelength. So speed in meters per second equals hertz, okay, which is this, times the wavelength. Okay, so wavelength was how long the wave is, and frequency is how many of those waves you get per second. The faster a wave is, the higher its frequency. Okay, and finally we have amplitude, which measures the amount of energy in a wave, and it's basically the height. So this wave right here has a small amplitude, and this wave right here has a larger amplitude. And you measure that from the normal line to the crest, or from the normal line to the trough. On a longitudinal or compressional wave, the denser it is, the larger the amplitude. So you actually measure the density, how many of these little waves in here are compressed together. Okay, and the larger the amplitude, as I said earlier, the more energy the wave has.